Hello, and I think we are live. Is my voice coming through? Do we have any audio problems this time? Hello, hello. Hi Pavani, hi Aditya. Important questions ever faster, Jippu. Aditya, if you don't want important questions, you can leave the stream. So we're going to discuss important questions as well as we're going to discuss a little bit more about the subject, individual units, how to prepare, and we're also going to be delving a little bit deeper into some key important topics. So that the aim of this particular stream is to give you the confidence that you can attempt your chemistry exam without any fear. Alright? So audio is perfect, looks like everything is fine. So Gopal Krishna, Namburi and Aditya, no audio problem, awesome. So I think we had changed the link of the live a couple of times, so a lot of people might be finding a little bit trouble in finding the stream. So please do share this link with your classmates or with your friends on your Instagram or your WhatsApp, whatever social media channels that you have. Please do share them. Let a lot more people find this link because they might be having a little bit trouble. Saket, Anna, exam is tomorrow, exam point of view, Japandi. Absolutely. Saket, the point of this stream is to kind of like, help you prepare for your exams. Okay, so we are going to discuss each unit in little bit detail. We're not going to take a lot of time. So the stream is going to be very short. It's going to be around 1 hour. And my aim is to give you a decent idea on each unit in this 1 hour. So it's going to be a difficult task. So I need you to also to keep up. I need you to kind of like, if you don't understand any topic, you can just rewind it a couple of minutes and rewatch it. Hopefully you'll understand then. If else, if you still have some amount of doubt in any particular topic, you can just leave them in the description. We'll wait 30 seconds more so we can allow people to join in. So come on, if you kind of like if you have the link with you, please do share them with your classmates. Let a lot more people come in. So once we have a lot of people started up, then we can initially start the stream and we can start off with unit 1. No problems. So pass Aditya, like I said, even in the previous stream as well, this stream is not only to make you pass. We aim for top marks here at Cynohub. And before I go any further, firstly, a huge thank you to all the students for making the past mathematics stream so successful. A lot of students have personally messaged me that Cynohub's mathematics videos have helped them a lot. So I'm really glad a lot of people studied their exams using Cynohub videos, and I'm also very happy that these videos were actually very helpful. So just in case if you're seeing me for the first time, seeing this particular brand for the first time, Cynohub is online learning applications built especially for B.Tech students. So when I was in B.Tech, when my team was in B.Tech, we had a lot of problems in terms of learning online. B.Tech students don't have any other platform to go online and learn, right? So for that reason, especially in terms of these exam points, these crucial moments where we need a person to teach us a subject, we have no one else to turn to. So that was the reason Cynohub was created. Cynohub consists of really excellent faculty from all across India coming down to teach you these engineering subjects in a very fun manner. Alright, so throughout this stream, we are going to refer through a lot of videos in our... What is your response in terms of yesterday's M2 question paper? Yeah, I saw the M2 question paper, Naveen. The paper was interesting. It was, sort of like the tips and tricks that we discussed. A lot of it came from that. The pattern was predictable, just like what we predicted in the previous stream as well. Yeah, absolutely. Also, one more thing what we're also going to do is, at the end of the stream, I'm going to share you the entire list of important questions from chemistry that you can absolutely learn to kind of like, crush tomorrow's exam. Alright, day after tomorrow's exam. So stay tuned, see the entire stream, watch, try to understand the concept that I'm going to be teaching you so that you get a lot of knowledge and it's not difficult for you anymore to kind of like, go start preparing for your chemistry exam. Perfect. Looks like we can start. Shall we start? Awesome, let's get started. So, firstly, what I want to do is get started with chemistry. What is engineering chemistry? Is the subject tough? How long is it going to take for you to prepare? So, firstly, what I want to say is engineering chemistry is the easiest subject in my opinion. So, I'll teach you why. So, the concepts that we're going to discuss today, they are going to sound incredibly easy. I'm going to make sure that you guys get the enough amount of confidence that you can tackle the subject head on, you can start learning your topics on your own, and a lot of help will be given obviously from the Cynohub team as well. So firstly, you go to the Cynohub website, and in the Cynohub website on the top you see subjects JNTUH and click on engineering chemistry. Okay, so a lot of the topics that we're going to discuss, a lot of the topics that the material that we're going to discuss, that we are going to be referencing here. Yeah. So we are going to be referencing from this particular section. So like I said, Cynohub is built for B.Tech students. Yeah, Pavani, BW, we have an incredible stream. We have a very, very fun faculty coming in. So absolutely not miss the BW stream. Okay, so I won't deviate any further. Okay, so yeah, the chemistry part. So Cynohub worked really, really hard to kind of like, build this chemistry course. A lot of the videos are very, very crisp, very, very sharp. They're right to the point. They deliver you that concept in 5 to 10 minutes time span that we have. And we know your attention span is a little bit less. So we want to give you the information as quickly as possible. Okay, so without any further ado, let's start with Unit 1. So what is Unit 1? Unit 1 is molecular structure and theories of bonding, right? So once again, this unit looks big, but it's not. Firstly, let's start off with what is atomic orbitals. So in the unit itself starts off with two main topics, atomic orbitals and molecular orbitals. We're going to discuss what is atomic orbitals and we're going to discuss what is atomic orbitals, molecular orbitals. But before I start, is my text visible? Is my handwriting visible? Is it legible? Is it visible? If you can read the text, just type what you're seeing in the chat. I just want to see what you guys are reading. So if it is visible, we can quickly continue. I'll just wait a second. So if it's not visible, okay. So basically, atomic orbital, it basically means it's an orbital, right? So for example, let us say what an orbital basically means. It's a probability of you finding an electron around the nucleus. For example, if I have this piece of thing, if I say this is an electron, right? This is my phone, but just consider this is electron. The probability of, sorry, this is an atom. Probability, and let us say this is the nucleus, and the probability of finding an electron around this atom, around this nucleus. I'm really sorry. So that is nothing but the orbital. If, for example, if you say, if you go to my friends and if you ask me, where can I find Vamshi? They'll just say around his house, right? I'll be somewhere around my house. So an electron will obviously be somewhere around the nucleus. So the probability of finding an electron around the nucleus is basically called as an orbital. And if the probability is somewhere, it looks something like this, right? The nucleus is like this, and if you can, if the path of the probability of finding an electron is basically a circle, that is called as S orbital. S for sphere, right? So sphere basically means not only to the sides but also to the top and to the bottom and to the right and left as well. And if the diagram of probability looks like this, like a dumbbell, it's basically called as a dumbbell. It looks like infinity, I know. It basically called as dumbbell. If it looks like a dumbbell, it's called as D. And if it looks like a double dumbbell, it is called as P. Alright, so all of these topics once again will be discussed in the first topic in the Unit 1. So if you can see Unit 1, Introduction of atomic orbitals. You can click on that, instantly you can find the S orbital, P orbital, D orbital, how these are structured, why these are named the way they are, and all of that. Okay, so those are atomic orbitals. Now we understand what is atomic orbital, but what is a molecular orbital? Molecular orbitals, nothing, they come out from atomic orbitals. They're nothing different, they're very, very simple. For example, let's just say we have two atoms. I'm going to be a little bit quicker, so you guys have to keep up. If you're not understanding something, please do rewind and rewatch it. So let us say these atomic orbitals have some amount of wavelength, right? Let us say I have two different atoms and we have this amount of wavelength. And when you combine these two waves, what basically happens is, see, the higher portions and the lower portions of these two waves are similar. Okay, I'll just go a little bit more slower, so I won't increase my pace that bit. Alright, so if the higher energy portions and the lower energy portions are inclined or in sync, what basically happens is it becomes bonding molecular orbital. Bonding molecular orbital, basically called as BMO. And there's another case. The other case is if it is like this. If the higher coincides or inclines with the lower, if the lower inclines with the higher, what basically happens is then you have to call it as anti-bonding. So bonding molecular orbital and anti-bonding molecular orbital. So it's that simple, right? So atomic orbitals, the probability of finding an electron. Anti-bonding and bonding molecular orbitals, basically, when you combine the wavelengths, whatever happens, that is bonding and that is anti-bonding. Once again, all of this is very, very detailed described in the video. And also, so do not forget to check out that particular video. So that is going to be very, very helpful. And the next important topic in Unit 1 is molecular orbital theory. we are not going to be discussing each and every single topic in every single unit, because that's going to keep us here for like 5 to 6 hours of stream, and we have a stream at 8 o'clock again. So that is for physics. Okay, so molecular orbital theory, right? Yeah, molecular orbital theory. I'm just going to write MOT, molecular orbital theory. This is also very, very important, and I hope you guys have bought your pen and paper with you. So whatever I'm saying, just try to note everything down, because this is going to act as a guideline for you when you're preparing for your exam. So molecular orbital theory. So do not forget, this is a very, very important topic that you absolutely have to learn. And once you're done with molecular orbital theory, then what you can do is, there is the molecular orbital diagrams of 3 different. Alright, so my writing is going to be a little shabby, I'm going to be a little bit fast, so you have to keep up. So the 3 different molecular orbital diagrams that you have to draw is for N2, O2 and F2. Out of these three, definitely there's going to be a question in the exam day after tomorrow, so absolutely be prepared. And the best part about this is, these are not hard. I'll just show you very, very quickly how O2 is. The formula is 1s2, 2s2 and 2p4, right? So for this, you can easily draw a diagram for 1s2. Is going to look something like this. And the same exact thing for 2s2 as well. And the same exact thing for 2p4, but there's going to be a small change. In middle of this, it's going to look something like this: 1s2, 2s2 and 2p4. Now, if you are wondering why does it look like this, why do we have to draw like this, and what if I want to draw the same exact thing for N2, and what if I want to draw the same exact thing for F2, you can absolutely go ahead and start referring to this particular lecture. Note down the name of the lecture as well: 6, 7 and 8. Can you see that? 6, 7 and 8. In the 6, 7 and 8, we are going to discuss how to draw the molecular orbital diagram of F2, N2 and O2. Also, the key important part, apart from just drawing the diagram, is that in the exam they are going to ask for something called as bond order. Note this down as well. Bond order is also very, very important. You absolutely should not forget. Bond order is very, very simple. The formula, half of number of electrons in antibonding minus electrons in bonding. That's it. It's very simple. You can keep that in mind. So whenever you're preparing for your unit 1, absolutely remember these 3 are very, very easy to learn. The faculty is going to do a lot better job. Is going to teach you that subject in a very, very easy manner. The N2, O2 and F2. Why do we need this sort of diagrams, and how do we go about drawing them, and how to find out the bond order after you have drawn the diagram. Alright, so that is the same exact thing that we're discussing at this point in time, but that is for N2. Okay, so absolutely don't forget to check out that video. It's going to be very, very helpful. And the best part is, in the video we're also going to discuss about how to find out the bond order of that particular problem. So that's going to help you a lot. So while you're writing your exam, the question is always like, draw the molecular orbital diagram, also find out the bond order. So you need both of them. So do not forget, once again, just to recap, bond order formula is half of number of electrons in antibonding molecular orbital minus number of electrons in bonding molecular orbital. So don't forget. Perfect. So that is the first section. That is the first section of unit 1. So once again, like I said, we are running very, very low on time. If I take this long for the first section of unit 1, we are going to stay here for a very long time. So just for that purpose, I think I'm going to accelerate the train a little bit. And once again, guys, like I said, do not forget, I'm going to be giving out the free important questions, entire document at the end of the stream. Do not forget, just stay tuned. At the end, we'll be sharing the important questions document. And the next part of unit 1 is crystal field theory. Crystal field theory we're not going to spend a lot of time on, because basically it's also a simple concept that once you learn it, a question from this particular segment of the unit is almost like confirmed, right? Crystal field theory, what does it mean, and why was it created? Before crystal field theory existed, did you know that there were 2 more theories, valence band theory as well as Weiss theory? The reason these 2 were eliminated and the crystal field theory was brought in was because this was doing a lot better job in terms of explaining the bonding interaction between metals as well as ligands. Bonding interaction between metals as well as ligands. You need to remember that. If you want to write that down, write that down. crystal field theory basically explains the bonding interaction between metals as well as ligands. So what is ligands? You can do a quick Google search, that will be a lot more easier, or you can absolutely go down. While we're explaining the crystal field theory, sir does a very incredible job in terms of explaining that. Alright, and coming down in the crystal field theory, we have a lot more. We have one more small topic called as tetrahedral as well as octahedral splitting of d orbital. Is it right? Yeah, tetrahedral and octahedral splitting of d orbital. I'll just write it down. Once again, if my handwriting is not visible, if it's not understandable, please let me know. Octahedral. Since I'm spelling it out, like, it's not going to be difficult for you. So tetrahedral and octahedral in terms of CFT. So like I said, in the first part of the unit, atomic orbitals, molecular orbitals, diagrams of N2, O2 and F2, and in the second unit, and in the second part of the first unit, CFT is a must. Do not forget CFT. And after that, go to band theory as well as doping. Band theory, it's not going to be very difficult. It's a very simple concept. You can just learn it very quickly. Also doping. Doping is not going to take you long to learn. It's very simple. I'll just tell you a quick gist of it. It almost seems like a story, right? So what basically doping is, in terms of when you have a semiconductor, right? If you have a semiconductor, it has two parts. The valence part and the conductance part. So what happens is, in the valence part, all the electrons exist. And when these electrons are able to move from this part to this part, basically the semiconductor is conductive, right? So doping, what basically it does is, it adds or introduces external material into this semiconductor, into this energy band gap, energy gap that it has. And in this gap, when you add an external material, the transfer of electrons becomes a lot more easier. That's it. That's just doping. That gist of it. So if you watch the video does a lot better job in terms of giving you in-depth and in-detailed explanation of what doping is. So just like that, we quickly wrapped up Unit 1. So I hope you have at least a bit of a fair idea of what Unit 1 is like, what type of concepts you can expect in Unit 1. Now that you have the basic understanding of these introductory concepts, like what is atomic orbital, what is molecular orbital, what is anti-bonding, what is bonding molecular orbital, how to find kind of like, the bond order, the diagram of N2, O2, F2, the doping, and how can doping help the semiconductor. It's just like that, we talked like a story. I told you like a story, you understood like a story. Tomorrow you're also going to write it like a story. So all of these concepts, that's it. When you sit down to prepare for yourself, they're going to be even more simpler. Alright, so I'm hoping I removed some amount of doubt or some amount of fear from your mind in terms of Unit 1. And next we'll start off with Unit 2. So if you guys have any sort of questions, please keep putting them in the comments. At the end of the stream, we are going to sit down, we are going to answer each and every single comment, and like I said, we'll be giving out an entire list of important questions, so do not miss out. So Unit 2, charging forward. So Unit 2 is water. Water is most possibly the most fun unit that you can learn, right? There is nothing way too complex, there is nothing way too hard. It's very easy, simple to understand. It's just that you need proper visuals to understand it. And that's what I'm going to do. Okay, what is this unit all about? This unit has two different parts. It's also just like, first half of a movie and second half of a movie. The first half of a movie, what you understand is what basically is hardness of water. That's who is the main villain. The hardness of water is the main villain. You're going to understand what is hardness of water, what kind of like, what causes it. And in the second half of the movie, what you're going to do is how are you going to defeat the hardness? How are you going to remove the hardness? How are you going to clean the water of not only hardness but also, other impurities and as well, the smaller gangsters that are there in the movie. So exactly, if you consider the Unit 2 as that, it's very simple. So exactly what is hardness of water? Hardness of water basically means is that, having magnesium and calcium salts in water. When you have magnesium and calcium salts in water, what basically happens is, when you're washing your hands, you might be remembering, if you wash your hands right now in your home, the soap will form a lot of foam, right? Foam or lather. But if you go to some other places when you are out traveling, when you're in some sort of remote locations, the soap might not form that amount of lather, right? So that's how you can differentiate if water is hard or if water is not hard. Okay, so and the reason why this happens is because of, once again, like I said, calcium and magnesium bicarbonates or salts. Okay, So that is hardness of water, and in terms of hardness of water, we have two different types. One is temporary hardness of water. One is a temporary problem, we can remove it. Another one is permanent, we cannot remove it. If you have an accident, you can heal, that is temporary. If you lose your limb, you cannot heal, so that is permanent. So in terms of temporary and permanent hardness, so temporary hardness, basically we can remove it by boiling the water. So in your cooker you might be seeing, whenever you're cooking rice or when you're boiling water, a white precipitate comes out, that is magnesium and calcium carbonates or salts, and that is temporary hardness. So you're removing salts from that water by heating, right? And permanent is, no matter what you do, those salts would not leave. Alright, so those are two different types. So you need to understand, so that's a sort of introduction for this topic. The next thing is, how do you measure the hardness of water? One is ppm, parts per million, calcium carbonate parts per million in water. How do you do that is very well explained if you go to this particular topic, unit 2, topic 2, how to measure hardness of water. Remember this, note down the name of the video. This is also going to be very, very helpful. A lot of good information has been given. So just check out this particular video and you'll understand a lot better. The next thing is the very, very important topic in this unit. You absolutely need to remember this, complexometric titration. Sorry if I'm not writing straight. If I write straight, I don't think that will be visible. Complexometric titration. I hope you are understanding what I'm writing. Okay, so what is complexometric titration and why are we going to use it? It's basically, one second, measuring the hardness of water using estimation of hardness of water by using complexometric titration. So in the complexometric titration, the process is very, very simple. I'm going to give you exactly 3 different steps. You need to remember this and you're going to write your answer very, very fine. Okay, so first what we do is, we take hard water, and in the hard water, we are going to add a little bit of EBT, Eriochrome black tea, alright. So this Eriochrome black tea is in blue in color. I'll just show you. Yeah. So once you do this, I'm sorry. So you can add the Eriochrome black tea, and once the Eriochrome black tea is added, what happens is this Eriochrome black tea reacts with the salts inside the water and turns into white red. It basically becomes a MEBT, metal Eriochrome black tea, and so what you do is, to that MEBT you add something called as EDTA. So step 1, add EBT to the hardness of hard water. Step 2, add EDTA to that MEBT. So EDTA basically means ethylene diamine tetraacetate. Alright. So if you add that to the MEBT, it basically converts back into steel blue, which means it can affect the color of EBT. Okay. So you just check out this video, that's it. It's just that simple, the complexometric titrations. So you just need to understand how do you write that in an exam, not just in terms of this vague manner. So just check out this particular video. This video is going to be even more detailed, a lot of information, and also you'll be able to easily answer the question when you get an exam. Also, complexometric titrations, very, very important, just absolutely note it down. So the first part of unit 2 is almost done. Like in the first part itself, we know a lot of things by now, right? What is water? I mean, what is hardness of water? How does hardness of water even come about? What can we So where can we find hardness of water? How do we measure this hardness of water? Basically ppm, if you remember. And how do you measure this hardness of water? By complexometric titration. So like I said, complexometric titration, three different steps. Hard water, take hard water. Add some EBT, Eriochrome black tea, it becomes MEBT, and to that MEBT add some EDTA, the ethylene diamine tetraacetate, and to that EDTA basically becomes MEDTA, and which the MEDTA, which basically is steel blue in color. Alright, so just refer to this video. The concept will be easily understood, like 5 minutes max you have to spend on this particular video. Alright, the second part of this unit is potable water. Like I said earlier, now we understood who the main villain is. The story is set. We need to we need to defeat the hardness of water. So second part is potable water. Potable water basically means drinkable water. In this particular small topic, you just need to understand what makes water drinkable, or what are the parameters that you need to consider before drinking a particular piece of water. Obviously, you and I are not going to consider those parameters in real life, but for chemists who have to determine that this water is drinkable, how do they do that? these are the kind of like, the parameters that they absolutely have to observe before kind of like declaring that the water is drinkable. So potable water is just as it is, drinkable water. Then we come into the main part, to the more interesting part, which is disinfection of water. Now that we have hard water, now that we have impure water, we have sewage water and all of these particular different types of waters, how do we disinfect it? How do we clean them up so that we can turn them back into potable water and we can drink that particular potable water? There are a couple of methods that we can do. The first two main methods, and also the very, very important methods for your exam, are chlorination and ozonization. See, just like that, talking by telling stories, we're already in Unit 2 and second half, chlorination and ozonization. So these two methods, very, very important for your exam. I'm just going to give you a brief explanation about what chlorination is. So chlorination basically means, you're passing chlorine gas through the water. Okay, that's exactly what we're doing here. So since passing direct chlorine gas is going to be a little bit difficult, you basically pass bleaching powder, CaOCl2, right? When you pass bleaching powder into the water, the bleaching powder reacts with the water and it generates chlorine gas as well as nascent oxygen. So it generates two different things. When you pass chlorine gas, it generates when you add bleaching powder to the water, it generates chlorine gas as well as nascent oxygen. Both of these are germicides, which means both of these are known to kill germs like, left and right. So when you add bleaching powder, it essentially what happens is the chlorination process is taking place, right? This is something that we see in our daily lives as well. We smell the water is a little bit of bleaching powder whenever people are trying to clean the water. Okay. So in terms of removal of microorganisms, exactly like I said, there are three different types that you absolutely need to know of: boiling, chlorination and ozonization, out of which these two are very, very important. And the best part about this is, once you understand chlorination, ozonization is almost the same, right? If I show you ozonization, it's going to look very, very similar. One second, let me just go to ozonization. Yeah, so like I said, so once you understand chlorination, it's going to be even easier for you to understand ozonization. See, just like I said, we're just going to pass ozone to the water, and since we cannot allow sunlight to kind of like hit the tube, we put it in a black room. So if you watch the video, all these three concepts, boiling, chlorination and ozonization, all three of these can be finished in like 10 to 15 minutes max, and you'll have a strong knowledge on how to write these questions if they appear in the exam, which they most definitely will. So like I said, chlorine, very important, ozonization, very important. Note these two down. And afterwards, we have a couple of other treatment methods as well. If you have time, please do go through them. These are also important. We don't know if these are like not very, very frequently asked, but these are also equally important. One is ion exchange method, reverse osmosis, once again very, very important. The less important ones are boiler feed, Calgon conditioning and phosphate conditioning. Boiler, Calgon and phosphate, easy to learn. Spend 1 hour of your time, sit down, just go through those videos, have a mental idea of what they are about, and it's going to be easy for you to write in the exams. But going forward, we're going to discuss one more small topic in Unit 2, ion exchange process as well as reverse osmosis. We're going to talk about reverse osmosis because this is also very, very important again. I hope you are writing down osmosis. Yeah, I hope you're writing down everything that I'm saying. I hope you're noting down the names of the videos as well, because while you're referring for these videos, it's going to be very, very useful. So chemistry, like I said, very, very interesting, very, very simple to learn. Kind of like, stories, that's just it, right? The things that we see in every single day. Okay, firstly, before we understand what is osmosis, we need to understand before we understand what is reverse osmosis, we need to understand what is osmosis. Osmosis basically means transfer of water from lower concentration to higher concentration. That's just it. And reverse osmosis is the reverse of it. Transfer of water from higher concentration to lower concentration. And because water doesn't usually go from higher concentration to lower concentration, we are going to put a lot of pressure on the water at the higher concentration state, which sir is also explaining very, very detailedly. So when you put a lot of pressure on the higher concentration, the water passes through a semi-permeable membrane, out of which it filters all the dirt particles, all the unnecessary molecules, and it gives out clean water. Right? Basically reverse osmosis, higher concentration, lower concentration. As we put up pressure here, this thing rises up. Okay, so reverse osmosis. It's once again, like I said, these concepts are very, very simple. And just like that, ion exchange method is also one of the most important topics in Unit 2, and you can find that here. So we're not going to discuss that right now, but you can absolutely go to Unit 2 and you can find the ion exchange method. Yeah, you can find the ion exchange method. Just sit down. This is also very interesting concept, very easy to learn. And the best part about this is you have a diagram. Whenever you have a diagram, draw a diagram. Sit down, prepare your diagrams very, very well, because the diagrams make sure they look neat, and also it kind of like indicates the person who's correcting your paper that you know the concept, right? Yeah, and the ion exchange video is like, 5 to 7 minutes. That's just it. In 5 to 7 minutes, if you can learn a concept, that's how incredible is that, right? Okay, perfect. So now we know Unit 2. Like, we're almost halfway through, and I hope you are learning a lot of concepts in the process. Let me erase everything. And now let's go back to Unit 3. So just like that, we're done with 2 units. Now you know most of the concepts that we talked about: hardness of water, temporary hardness, how do you measure the hardness of water, complex material titrations, disinfection of water, chlorination, ozonization, and we also talked about potable water, ion exchange, reverse osmosis. Now, don't these terms sound familiar? Don't you feel like you know at least something about these terms? That's the aim of this particular live stream. And the whatever is behind me, what are the topics that are behind me, these videos are going to help you 10 times more in terms of understanding these concepts a lot better in terms of writing these concepts in your exams. Okay, so just if you're wondering where you can find these concepts, you can go to www.cynohub.com, and on the top you can find there is a small section called as subjects, and inside that you can click engineering chemistry. You can click on engineering chemistry, and you'll get a list of all the subjects, all the topics divided neatly in terms of categorized, neatly in terms of units. So there it is. You can click on this subjects, and you're going to get all the subjects basically if you want. And engineering chemistry is also here, right here. So since for your exam you have the engineering chemistry day after tomorrow, you can do this. And thousands and thousands of students have referred to our mathematics materials, and I have received enormous amount of positive response that it helped a lot. So firstly, once again, thank you so much for that. So I hope you find the same amount of value in engineering chemistry as well, because chemistry, a lot of effort was put into it. The entire subject is very, very interestingly created. So I hope you enjoyed. Also, let's come back on track and let's go to Unit 3. Unit 3 once again is also a very, very interesting. It's not difficult. Stereochemistry and corrosion. Okay, so these two terms. Corrosion is something that you and I are familiar with. Stereochemistry is it? Sorry, electrochemical cells. Electrochemistry and corrosion. Okay, yeah, electrochemistry and corrosion. Okay, so corrosion, you and I know what is electrochemistry. Let's find out. So firstly, before I go any further, let's talk about what is an electrochemical cell. Exactly in this video what we have. Okay, what electrochemical cell is something, a battery that we find in our day-to-day lives, right? We have a battery, the 9-volt battery which we have laying in our house. Do you remember that? The blue and white one. So that is nothing but an electrochemical cell, also called as a galvanic cell. So remember, if in your exam, if you get a question saying that describe or draw the diagram of an electrochemical cell or a galvanic cell, remember that these two mean the same. And the construction of it is very, very simple. Just like it is in the diagram, you need 2 electrodes, zinc electrode and calcium, zinc and copper, and you have to dip them in zinc sulfide and copper sulfide. 2 buckets of zinc sulfide, copper sulfide, zinc electrode, copper electrode, that's it. This becomes anode, this becomes cathode, the zinc undergoes oxidation and the copper undergoes reduction. Perfect. And in the battery as well, you have the minus and plus signs, right? The anodic part, or the part containing the zinc sulfide is the minus, and the cathodic part, or the part containing the copper, is the plus. And the whole circuit is finished once you attach a small salt bridge onto it, and the way you get electricity is by attaching a copper wire. Okay, so just like I said, if I have to draw it, you just have two different solutions, zinc sulfide and copper sulfide. In between you have a small salt bridge. This is going to complete the entire circuit, and this is the copper wire with which you can get the electricity from. Okay, this is a very, very efficient method, and this is also an important concept for you to understand the remaining of the unit. So do not forget, absolutely make sure you remember this to understand this particular concept. Okay, so in terms of after electrochemical cell, so now we understand what is a galvanic cell. Okay, galvanic cell is nothing but electrochemical cell, is nothing but a battery that we have in our home. Okay, so what is electrode potential? The next very important topic. So note this down as well. Electrode potential, note this down, make a star mark onto it, because electrode potential is also going to be very important. So what electrode potential basically means is that, you know, the maximum amount of the maximum potential of an electrode. If I have an electrode, the potential of this electrode to undergo the maximum amount of reduction or the maximum amount of oxidation, how far can it go? That's the kind of like, you know, electrode potential. And in terms of electrode potential, we also have something called as standard electrode potential. So this is going to be very important as well. So it's just an extension of electrode potential. Once you understand what electrode potential is, you can also easily understand what standard electrode potential is. I'm almost losing my voice. So if you're understanding, just leave a comment in the comment section. Just let me know if you're understanding, and if you want me to repeat anything else. So if you want me to repeat something, let's go over that at the end of the stream once again. Yeah. So this is electrode potential. The ability of the electrode kind of like undergo reduction or oxidation. To what extent is electrode potential? And the next concept is standard electrode potential. What is it? Standard electrode potential. If we have electrode potential, why do I need standard electrode potential, right? So that you can absolutely learn in this particular video. This is also very important. Do not skip it. What is standard electrode potential? You need to know. So sit down, look at it, and you understand. It basically means, you know, having a fair ground for all electrodes, kind of like when you're measuring the electrode potential. I'll just give you a quick brief. For example, let us say I have 3 different electrodes, right? And out of these 3 different electrodes, I want to find out the electrode potential of let us say all these 3 electrodes. Now, if I start measuring the electrode potential of this electrode here, and after a while here, and after a while, you know, the other electrodes as well, what happens is there might be changes in temperature for each experiment, right? The temperature here might be this much, the temperature here might be this much, or something like that. And the environmental variables might change, the atmospheric pressure might change, the solution might change, you know, human errors basically. So to avoid all of this, the standard electrode potential basically gives you three different you know, conditions you need to have before you measure the electrode potential of an electrode. That one is having 1 molar solution, second is 1 atmospheric pressure, and third one is 298 Kelvin. Okay, these three parts. If you just go through this video, standard electrode potential, note it down. It's going to be very easy for you to understand. Perfect. Alright, so just give me a 30-second gap for me to kind of like, you know, regain my voice. In the meantime, what you can do is, if you're finding the video helpful, if you're enjoying the stream, please do share this stream with your friends in your class groups, in your Telegram groups, in your WhatsApp groups, on your Instagram, wherever it is. If you're sharing it on Instagram, do tag us. It's at Cynohub. It's CYNOHUB at Cynohub, CYNOHUB. And we have a lot of more streams coming up for the next exams as well. So we have a stream coming up for programming, we have a stream coming up for BWE, we have a stream coming up for other branches later this night for physics as well. So if you're enjoying the video, please help us out by sharing this on any of your social media platforms. So if you're once again, if you're posting on Instagram, tag us at Cynohub. Alright, now that we have that out of the way, let's talk about different types of electrodes. The next part of unit 3. It's in the same subsection, the first part of unit 3. You know, each unit is like a sequel of Marvel movies. You know, first part of unit 3, second part of unit 3. All of them are connected, and all of them lead kind of like, you know, the ultimate end goal of making you understand electrochemical cells as well as corrosion. Okay, the second part of unit 3 is that, you know, types of electrodes. Okay, now that we understand what is standard electrode potential, how do you create a battery, and what is electrode potential in general, now we need to understand what are the types of electrodes that we have. Types of electrodes, basically we have 3 different electrodes. One is calomel electrode. It is also called as reference electrode. Also note this down. If in the exam, if he asks you briefly describe what is a reference electrode or briefly describe what is a calomel electrode, just understand that, you know, both of these questions mean the same thing. Calomel electrode or reference electrode both mean same thing, and the other two are quinhydrone and glass. Quinhydrone and glass. Okay, so calomel electrode is going to be very important. Note it down, compulsory, almost. And quinhydron and glass electrodes, there is a very good chance that they might ask you the working, how do they work, alright? The working of quinhydron electrode and the working of glass electrode. And for caliber electrode, you do have a diagram. So make sure, once again, like I said, I cannot stress this enough, make sure you know the diagram well. Make sure you understand the diagram well, okay? So caliber electrode is also called reference electrode. Make sure you know that. And one more very, very important topic in Unit 3 is Nernst equation. NERNST, Nernst equation. You might be pronouncing it a little bit different than I am. You might be calling it Nernst equation. Nernst equation, either way doesn't matter. You get the point. So Nernst equation also you need to absolutely understand. One more very important concept is electrochemical series. Is it visible? Yeah. Electrochemical series. So also, if you're not subbed to the channel, also make sure you subscribe and also hit the post notifications so that whenever we add or we come up with a next beautiful live stream, you can easily understand, you easily know and come down and visit the live stream. Okay, this is the first part of Unit 3. Okay, so first part of Unit 3, not very difficult. Like I said, what is galvanic cell? One thing. What is an electrode? What is standard electrode potential? And what is electrode potential firstly, and then you go to what is a standard electrode potential. Once you know these two, just start to learn about types of electrodes, calomel electrode, quinhydron, glass. Like I said, calomel is very important. It has a diagram. Also does quinhydron and glass. So you can check out all of these videos right here. Like I said, the things that we've been talking about, the calomel electrode and the calomel equation, any problems on that, quinhydron, Nernst equation, electrochemical series, so all of these are very, very important, alright. So these topics, the best part about these are, they're important at the same time, they're interesting. Wasn't that fun learning these 4 concepts very, very quickly? Okay, so that was the part 1 of Unit 3. Then we go to part 2. That is, what is it? Part for Unit 3, I think it's corrosion. Yes, corrosion. Very, very simple to learn. Very, very easy to score. Corrosion is something we see in our day-to-day lives. Like for example, if I go around this room, I can easily show you one spot where some metal is being corroded. Even this one has some amount of corrosion on it. I don't think you can see it on camera. So corrosion, right? So why does corrosion happen? To answer that, it basically means, when we have a metal and when it undergoes oxidation, rust forms or rust is created. That's it. That is corrosion. So once you understand why something exists or how something forms, it's very, very easy for you to kind of go through the entire thing like a breeze. See, like I was saying, see, all of these are kind of examples of corrosion. In the video here, we go into a lot more depth. We explain you, we give you details about how different surfaces form, different categories or different kind of environmental variables contribute to corrosion. Alright, so once we have the corrosion concept in mind, we have 2 different types of corrosions. One is dry corrosion, one is wet corrosion. What is dry corrosion? Dry corrosion is when we have a metal and we just leave it out there. Kind of when we leave it out there, when atmosphere reacts onto it and when it creates rust, that is called as dry corrosion. Whereas there are sometimes we have underground pipes that have to take a lot of water or take through water. If the corrosion is being formed due to water or due to liquid, that is wet corrosion. Two different things you need to absolutely remember: dry corrosion, wet corrosion, very simple. So after that is done, after that is done, we are going to talk about different variations of corrosion. One is galvanic corrosion, basically the corrosion that we can see in our electrochemical cells. We discussed in the first video, galvanic cell, if you remember that. The rust or the corrosion that happens in that is called as galvanic corrosion. Pitting corrosion, waterline corrosion, all of these. Pitting corrosion is also very, very interesting. The video that we have here in terms of pitting corrosion, I would say it's the best. A lot of very, very detailed step-by-step process of how that pit of a corrosion, that pitting corrosion actually happens, and how rust forms, how the cathode forms, or how the anode forms, in what conditions. I think absolutely, I would definitely recommend you to check out that particular video. Alright, so now that the corrosion part is done, the types of corrosion part is done, there is also one more thing that you absolutely need to go through, that is factors affecting the rate of corrosion. Factors affecting the rate of corrosion. Okay, this is the lowest I will go. After this, I'm going to erase everything and I'm going to come back again from top. So, factors affecting the rate of corrosion. Once again, this won't be asked as a single question in itself, but it might be asked as a part of a longer question. So, it's also very simple. A couple of factors. Just need to understand under what circumstances does corrosion occur, and if you can just list down those factors. It's also a brief storytelling sort of an answer. So, it's very easy to learn, very easy to memorize as well. So, absolutely make sure you go through these factors affecting corrosion, and just like we did with unit 2, finding out hardness first and then solving the hardness of water, we're also going to do the same exact thing for unit 3. We are going to have to move a little bit quicker because we're running out of time. So once again, like I said, if you want to sort of have a reference to any of the videos that we're discussing, absolutely go to www.cynohub.com, or you can go to Google Play Store. We're also on Google Play Store. Search for Cynohub. It's Cynohub. You can download the app, and the same amount of all the high quality lecture videos, study material, previous year question papers, and a lot of good stuff, you can find it on the app. So you can go to Google Play Store, search for Cynohub. And while this is happening, what I'll do is I'll just write down the next topic, which is control methods of corrosion. How can you control corrosion? Right? Because if you leave corrosion as it is, it's going to destroy a lot of things, right? So eventually if a metal corrodes, it basically destroys itself, right? So even if your water pipes get corroded, whenever you open your tap, you basically get dirty water, right? So all of these factors or all of these consequences that we get due to corrosion needs to be stopped. How do we stop it? For that, we have a couple of methods. The first one is cathodic protection. This video. So cathodic protection, like I said, we're not going to be going in depth. Protection. I'm going to just give you the important types that you absolutely need to remember. One is cathodic protection, one is sacrificial anode, and one is impressed current cathode. One is sacrificial. Do I have to write it? Sacrificial. And one is impressed. Sorry for my handwriting. It almost feels like, Egyptian code or something. Alright. So one more thing is electroless plating of nickel. This is also very, very important. It has been repeated many times. Note this down: electroless plating of nickel. Electroless plating of nickel. The best advantage of people going through the live right now is that you can easily understand what I'm writing. If someone checks back and just randomly jumps onto this point, he won't be able to understand or decipher whatever it is. Alright, so electroless plating of nickel is very important, and in terms of cathodic protection, very important. Sacrificial anode, very important. But cathodic protection, the priority goes up top. So make sure you understand what cathodic protection is. Make sure you understand what electroless plating is exactly. This particular video, number 15. Note down the number of the video as well. Number 15. It's going to be very, very easy for you when you're kind of revising. Since the Cynohub is also available on the app, you can also even study on the bus while you're going to an exam. Even your exam center is going to be very, really easy, and also it has a lot of lecture notes as well, which you can quickly refer. So I absolutely recommend having the app installed on your phone, as well as keeping the website handy as well. Alright, so that was unit 3. So unit 3, once again, nothing too difficult. Firstly, yes, it's a bit large, but the best part is, it's huge, but it has two simple concepts, right? Firstly, the electrochemical cells, the series as well, which is important. So galvanic cell, we talked about galvanic cell, we talked about electrode potentials, we talked about standard electrode potentials, we talked about different types of electrodes, and then we also talked about Nernst equation, electrochemical series. Then coming back to the second topic, corrosion. Once again, what is corrosion? How does corrosion happen? What are types of corrosion, dry and wet? And also galvanic water pitting, and also other corrosion, which I hopefully you noted down. Galvanic pitting and water. But whatever it is, I definitely recommend you to check out the pitting corrosion video on Cynohub. The explanation in that is top notch. I absolutely assure you that. Okay, and once again, how to control corrosion. Cathodic, sacrificial, impressed, cathodic protection, and electroless plating of nickel. Okay? I hope you are not tired. I've already lost my voice. So those were the first 3 units, and just like that we're almost through a majority of the portion in the subject. So if you are able to understand what I said, if you're able to, if you're able to grasp the simple introduction concept that I gave you, it will be even more easier for you to kind of when you sit down, kind of open your notes or open the Cynohub videos, or whenever you start your preparation, it's going to be very easy for you to kind of quickly run through the entire subject in kind of a matter of a day. Since you have the entire day tomorrow and also the entire night tonight, I would say sit down, absolutely make sure you're going through each and every single topic in a lot more detail and a lot more understandable manner, such that you don't lose upon details. The problem is when you kind of learn concepts on a fly, or kind of learn concepts vaguely, you miss the details that make the answer, right? Or make the concept the concept. So anything, one thing that you have to take away from this particular live stream is that always focus on the details. Always focus on the micro minimum details that come along with the clarity of concept. All right. So let's go to Unit 4. So Unit 4 will not be spending a lot of time, and we're already way too late. We'll quickly jog through Unit 4. So Unit 4, the first part is isomers. We have a couple of concepts revolving around isomers. So once if you understand isomers, I think it's going to be easy for you to kind of understand the remaining concepts as well. What is an isomer? Isomer basically means different chemical compounds having the same formula but different structures. Okay, I do the same structures. Let me change it. Different chemical compounds having same formula but different structures. Okay, hopefully it makes sense. It's sort of like not children's toys. Different structures. Okay, same formula, different structures. And in the under isomers, you also have geometric isomers. We also have E and Z isomerism. So these two topics are, once again, are also sort of important. Once you understand isomers, I think it's going to be kind of an extension of those topics. So if you sit down, if you go to Unit 4 right here, structural isomers, and you can also start to learn geometric isomers, enantiomers. One second, go to water. Give me 5 seconds break. In the meantime, just look through the Cynohub website. Just look through all the videos and all the concepts that we talked about up until now. Just see if you can spot them and just note down the numbers. Perfect. Let's get back. Alright, in the Unit 4, there is a very important concept called as chiral carbons. If you understand chiral carbons, you can easily get 2 more topics. One is optical activity, and another is plane polarized polarized light. So understand chiral carbons. In your syllabus, you have a topic called as optical activity as well. So if you get the optical activity, in that you're going to easily find what is a chiral carbon. See, it's a very interesting topic. Absolutely, you have to check it out. So chiral carbons as well as plane polarized light. What is a plane polarized light, and what is chiral carbons, and all that you're going to understand very soon once you watch those videos. And coming to the second part in terms of Unit 4, it's basically isomers. When you kind of it's a little bit in depth of isomers. Sit down. It's kind of like, I know it's a little bit dry concepts. But if you just sit through these, if you can just refer to these incredible videos, they're going to make it very interesting, and you'll be able to easily understand the concepts. The second part comes in, enantiomers and diastereomers. So what are enantiomers and what are diastereomers? Enantiomers are stereoisomers which are mirror image of each other but are not overlappable. We have a very good example in the video. Let me just pull that video up. Enantiomers and diastereomers. Note it down, enantiomers and diastereomers as well. Also really important. Yeah. Once again, I'm stressing, do refer these videos. They're really well done. They are incredibly high quality. A lot of it has really nice animations and all of that. So when you're trying to understand a concept, yeah, exactly. Mirror image. So my hand and my hand, these are mirror images, but when I overlap them, they are not exactly identical, right? So those are enantiomers, and the stereoisomers, which are not mirror images of each other, are basically called as diastereomers. So once again, two concepts sounds complex, but when you kind of sit down and picture like this, it's going to be very simple. All right. So if you just go through the enantiomers video, I think this is going to be really easy to understand. We go into a little bit more depth, what kind of compounds that you can find this in, and and also what are the other applications of this. So sit down, go through enantiomers and diastereomers. These are also very important concepts. Note them down. And in terms of finishing off the first part of Unit 4, the one more concepts or two more small concepts that we have is, one is conformational analysis, energy level diagram. The conformational analysis, just note it down once again, important part. Conformational analysis. It also has an energy level diagram, so just make sure you go through the whole entire concept. Also, if you have any sort of questions, once again, you can just refer to this video. A lot of incredible stuff, like I said. We actually created those physical objects of these molecules, a lot of good stuff, so you'll be able to easily understand once you just watch the video. Alright, the last thing is aspirin and paracetamol. So this is almost like, a very important question. It's going to be kind of like, it's frequently repeated, also very easy to learn, because aspirin and paracetamol is something that we use on a regular basis, right? Hopefully not regularly, but whenever we come across them in our day-to-day life, aspirin and paracetamol. So in that, you're going to be asked about the chemical formula, you're going to be asked about the structure, you're also going to be asked about the synthesis. So just note them down. Chemical formula, structure, synthesis of aspirin and paracetamol. Important concepts, a little bit tricky to understand. So yeah, this one is a paracetamol video. So really clean and impressive visuals. So if you want to just kind of understand the concept a little bit better, having this video in hand is going to be really helpful. And this one is the aspirin. So wherever you fall down, the thing which you apply is the I think it's regularly called as spirit. I think that is aspirin. So if you these two, just understand chemical formula, structure, synthesis of aspirin and paracetamol. With that, we have kind of pushed aside the first part of Unit 4. Unit 4 is once again a huge, massive unit. A lot of concepts, a lot of different concepts. So you're going to need a little bit more help in terms of Unit 4. And one thing is, whatever you do, absolutely do not skip any topic or do not skip any concept from Unit 1, 2 and 3. Because Unit 1, 2 and 3 are interesting, simple, and they're going to contain a lot of the majority marks in. If you are perfect, if you can easily sit down through 1, 2 and 3, you can name each and every single topic in that, also the concept, I think you're easily going to score a lot more marks. Alright, the next thing is types of reactions. We're almost ended the Unit 4, man. So types of reactions. Types of reactions, once again, it's a very simple story. We have three different types of reactions: elimination, addition, substitution. The three basically define themselves. Elimination is something that we, you and I know, right? If you watch Big Boss, you know that people get eliminated. It's almost very similar to that. And the other thing is addition, adding another person, which basically means a wildcard entry, I guess. And the third one is substitution, sending one person away and bringing one more person in, substitution. Okay, these three terms you have to kind of relate in terms of chemistry in your particular subject. So if you're able to do that, types of reactions is also not very difficult. And the next thing is Markovnikov and anti-Markovnikov. Just sit down. These two are also very simple: Markovnikov and anti-Markovnikov. Note them down. Important topic. Not a huge, massive concept, very simple, very easy to learn, 5, 10, 15 minutes, you can easily understand. So Markovnikov and anti-Markovnikov also kind of try to understand. And last two things is Grignard and Zaitsev rule. Okay, so Grignard and Zaitsev rule, once again, simpler concepts, they sound complex, I know, but if you sit down, if you go through the entire videos, you'll be able to understand what these two are, how to kind of like, tackle them, and a lot more. So that was Unit 4. I know Unit 4 was a lot bigger, it was a lot more massive than what we discussed. So Unit 4 is something that if time permits, try to focus a little bit more on, but if you're starting your preparation right now, if you're starting your preparation with this video, what I absolutely suggest is finish Unit 1, 2, 3 and 5. These are the most easiest topics, easiest units, and then you can sit down to Unit 4 so that you'll have a lot more clarity and you'll have a lot more confidence that no matter what, you'll be able to easily go through the exam, and hopefully you'll be able to score more than normal marks. You'll be able to score top marks. Always aim for more than 70% or 80%, that's what, it's difficult, I know, but with the help of Cynohub, you're absolutely able to do that. Okay, so let's quickly wrap up with Unit 5. Unit 5 once again is very simple, very easy. I'll just give you a quick brief explanation about a couple of topics. With that you can easily understand. The first topic is spectroscopy. What is spectroscopy? Spectroscopy is a study of kind of like the interaction between matter and radiation energy. All right, that's it. So once you understand that, it's very simple. What is radiation energy? Radiation is energy nothing but the entire visible spectrum, everything that we see, ranging from gamma rays to kind of like your high frequency waves to kind of like your low frequency waves, like radio waves, the waves that you get for your television, and high frequency waves like gamma waves. Okay, how does matter react to this radiation energy? That is the entire study of spectroscopy. And the next part is even more simpler, principles of spectroscopy. The principle of spectroscopy basically means that if there is a matter, if this is a matter, I hope you can see, okay, it's getting transparent. Let's just take one particular object. Yeah, if this is the matter, and if this matter is exposed to radiation energy, what can happen? The energy can be absorbed, the energy can be reflected back, the energy can be transmitted, or the energy can be scattered. All of these things can happen, and that is the principle of spectroscopy. It's almost on the same exact lines. It's that simple, right? So once you understand this, I think it's written very clearly here. So if the matter is exposed to electromagnetic radiation, the radiation can be absorbed, transmitted, reflected, scattered, or can undergo photoilluminance. Alright, so that is principles of spectroscopy. The next part is the UV spectroscopy or the visible spectroscopy. In the Unit 5, these are two more concepts that you need to understand. Once you understand the basic fundamentals of spectroscopy, these are not going to be very difficult, the UV spectroscopy and the IR spectroscopy. You're not going to touch more upon them at this point in time. So these are something that you just kind of like have to go through. You can just refer to these videos, and once again, like I said, these videos are how many minutes? 10 minutes, and you'll be able to understand UV spectroscopy. So if you are facing troubles, if one of your friends doesn't know any particular concept, please do refer them these videos. These videos are taught by very experienced professionals, so they know what they're talking about. The faculty has taught thousands and thousands of students, so he'll be able to give you the exact information that you would need for you to kind of like, go into the exam and don't think about anything and just write about that answer. All right. So spectroscopy, also make sure you read about UV spectroscopy and IR spectroscopy, infrared and ultraviolet. All right. So nothing complex, very simple concepts. You can understand that. No tension. Then two more important concepts in Unit 5 is simple concepts, short concepts but important: chemical shift and vibrational and rotational spectroscopy. Chemical shift is almost very important. Chemical shift. Go through the video, try to understand. It's very simple concept. If you understand chemical shift, it's going to be really easy kind of to remember. And this is the first major half of Unit 5. In the first major half of Unit 5, it's very simple. We understand what is spectroscopy, we understand what is principles of spectroscopy, and then we can easily learn what is ultraviolet spectroscopy and what is infrared spectroscopy, right? So take these three and you should have a strong knowledge in terms of Unit 5. And the second part of Unit 5 is even more interesting. That is NMR, nucleomagnetic radiation. Now, if you stay with me for a couple of minutes, I'll give you a very, very simple trick to understand NMR. The same exact tip is also given in the video. So if you are watching the video again, you'll be able to understand it even more simply. So NMR, right? How do you remember this? What does it even mean? So if you're wondering this, let me just break it down. Very, very simple. Nucleomagnetic resonance, right? So I hope you're writing it down. Magnetic resonance. What does it mean? Nucleo basically means nucleus, alright. Magnetic waves, magnetic field, resonance, resonating. So when you pass the magnetic field through the nucleus, it resonates. That's it. That is NMR. Okay, it's not really that's it, kind of like, it's a gist of it, what basically NMR is. And if you want to remember NMR, I think this is the perfect way to do so. Nucleomagnetic resonance, alright. So nucleus, when you pass it or when it goes through magnetic field, it kind of like resonates. The resonation, it basically splits itself and kind of like, creates this lower energy state and higher energy state, and kind of like, bounces between both of these. Once again, if you just go through the video, it's going to be very, very interesting concept, because NMR or MRI, these are concepts that we kind of like, hear about in our day-to-day lives. One second, and my voice is entirely gone. The strength that I had in my voice in the start of the lecture. Hopefully you're able to still understand what I'm saying. So nucleomagnetic resonance, very simple tech. So if you don't know anything about NMR, just remember this. Nucleomagnetic resonance. Alright? Kind of the name itself gives it away. So in this one, what actually happens is, so these atoms, they kind of like, rotate in clockwise or anti-clockwise directions. So when these are rotating in terms of anti-clockwise or anti-clockwise directions, like we see here, all of these are kind of randomly rotating. They're all over the place. There's no law, there's no order. So what we do is we pass magnetic field through it. So once we pass magnetic field through it, every single one of them gets in line, into the lower energy state as well as the higher energy state. These kind of like differentiate itself, kind of like they move themselves apart and into their respective positions. So that is NMR. So while you're learning NMR, these sort of demonstrations, or yeah, exactly this particular concept, super easy to remember. Nucleomagnetic resonance, easy, super easy to learn, super easy to understand. So the whole entire video series has a lot of incredible tips just like this, kind of like, to easily make you understand the concept. At the same time, not kind of like, deviating a lot more from the concept as well. So it's 7 minutes in NMR. The whole entire concept will be very, very clear. And also the exact thing, yeah, the nuclei will be spinning in clockwise as well as anti-clockwise direction, and they will be all over the place. And also while they're spinning, they create a small tiny magnetic field as well. Alright, so they will be all over this place, and when you pass a magnetic field through it, all of them come across in one line, and they kind of like arrange themselves into a higher energy state and as lower energy state. Before they were like this, when you pass an electric field, that happens basically. Alright, so once again, like I said, very interesting video. Note down the 6th video in Unit 5 NMR. Very, very interesting, also very, very important. The next part is conditions for NMR activity. So if NMR is supposed to happen, what do you need? How do you make NMR happen? Or what are the conditions such that NMR actually takes place? So for that, this video is going to be very, very helpful. 2 simple conditions. You just need to understand both of these. Just need to be able to elaborate on both of these, and it should be easy to go. And one more small tip, while you're writing big questions in your exam, if there is a big massive answer that you're writing, always try to divide it into multiple points, point 1, point 2, point 3. If it's a massive big paragraphs, it becomes difficult for the examiner to read. So instead, if you divide it into multiple points, it becomes very, very easy to correct. And also, when you ease the stress of the examiner, or when you ease the work that the person who is evaluating your paper, ease his amount of work that he has to put into, the evaluator easily gets into kind of a good mood. He thinks that the student knows his stuff the writing is clean, the diagrams look neat, a lot of spacing has been given, the answers have been divided into multiple points. A lot of these, when you do this, you know, evaluators tend to give you good marks, alright? So tomorrow while you're writing your exam, if you're writing massive paragraphs of answers, try to break them down into multiple paragraphs or into multiple points. That becomes easy, very easy for the evaluator to read, alright? And finally, NMRI, nucleomagnetic resonance imaging, alright? It's just an extension of NMR, and I think we're almost way too late. How many of you guys are still on the stream, kind of like, you know, say AO? So MRI is also something that we come across. We know, right? MRI, that's a brain scan of it. Okay, so how MRI works is also very simple. It's also on the same terms as NMR. Like I said, when the magnetic field passes through these nuclei or they sort of kind of like arrange themselves, or kind of like they change their position. They change their position from lower energy state, or kind of like, you know, they change or they align themselves into lower energy as well as higher energy states, right? And this change we are going to we are able to kind of like, you know, identify, or we are able to kind of like picture it. So yeah, this is sort of like the actual practical example, the brain of a normal human being as well as the brain of an Alzheimer's person. So a small cavity here, a small kind of like, you know, space that indicates that the person has Alzheimer's. Okay, so all of this is done basically by using an MRI. So while you're learning this particular unit, I think it's going to be filled with a lot of interesting examples. So whenever you're working on chemistry, it's always best for you to kind of like understand and remember where do you even apply these concepts, right? This one exactly. Where do you even apply these concepts? When you understand where do you apply these concepts, you can find a lot of easy to learn information from. Okay, so I think that is a wrap for today. So we discussed all the 5 units. I'm just going to quickly go through one last time about all the 5 units so we can understand what we talked about today. Once again, any sort of questions, any sort of topics you are unsure about, you don't know, or if you're looking for someone to explain, really high trained professionals on the Cynohub are going to explain you. All of these topics are divided into Unit 1, Unit 2, Unit 3, Unit 4 and Unit 5. Each unit is divided into multiple subsections. Each topic 10 to 15 minutes. If you can just spend 15 minutes of your time, you'll be able to easily understand the topic and you'll be able to easily crush that question if it appears in your exam. Alright, coming back, Unit 1, atomic orbitals, molecular orbitals, we talked about those. Molecular orbital theory, if you have to draw molecular orbital diagrams of N2, O2 and F2, you absolutely need to refer those videos. We talked about how to draw O2, right? So, and in Unit 1, bond order is very important. Basically bond order, do you remember the formula bond order? If you don't, just write it down. Half of number of electrons in anti-bonding molecular orbital minus bonding molecular orbitals, and that is the entire thing. 1/2 of electrons of ABMO minus BMO. Alright, electrons. Half of, when I say half of, it's that. Alright. So do absolutely remember the bond order and also understand how to find out the bond order of N2, O2 and F2. These 3 things, one of them is absolutely going to come down in your exams. So make sure you are prepared for that. And the next thing is crystal field theory. Crystal field theory, like I said, once you understand the concept, it's a lot more easier to kind of like, get into. And in that crystal field theory, we have splitting of d orbital in terms of octahedral and tetrahedral. Which also kind of like, they're easy to understand. You just have to sit down and just go through the topics or go through the videos. Next, band theory of solids or doping in terms of to help a semiconductor improve its conductance. So do you remember that concept that we talked about earlier? So for a semiconductor, we talked about 2 different segments, and there is an energy gap for electrons to kind of like transfer from valence band to conductance band. And when they do, basically conductance happens. So under low temperatures, semiconductors, basically that's the reason why they are inductive in low temperatures, and high temperatures they are conductive. And so introducing foreign materials into this energy gap helps the semiconductor kind of like, become a lot more conductive, right? So that is kind of like, effect of doping on semiconductors. So absolutely go through that. It's also a very interesting video. You'll be able to easily understand it, and that's for Unit 1. And Unit 2, very quickly recap, jogging through, even running through the entire syllabus. Hardness of water. What is hardness of water? How do you identify hardness of water? Where do you find it? How do you measure hardness of water in ppm, if you remember? And how do you measure the hardness of water using complexometric titration? the EBT and EDTA method. This is going to be the most important topic in that unit. So doesn't matter what you skip, do not skip that particular part. And like I said in the video, it's very detailedly explained. So EBT, areochrome black tea, and EDTA, ethylene diamine tetraacetate. So we also talked about the three-step process for that question as well. So if the question appears in your exam, you know what to do, you know what to write. So in going forward, we have potable water, basically drinking water. And once we have potable water, you know that we're going to talk about how do you convert impure water or hard water into pure water or potable water. There are different methods of doing that. Reverse osmosis, which we saw, very simple to learn. Ion exchange method, which we did not see, but very simple to learn. Disinfection by chlorination and ozonization, super simple to learn, but also very important. Chlorination, I hope you noted it down. Ozonization as well, I hope you remember both of these concepts, because they're not very different from each other, and they're also very easy to learn. And with that, we've also even swooped up Unit 2. So coming back to Unit 3, going forward to Unit 3, we have two different segments, electrochemistry or electrochemical cells, and corrosion. Electrochemical cells, we talked about what is a galvanic cell, how a battery is made, do you remember the two different sulfate solutions? And we also talked about electrode potential, we also talked about standard electrode potential, and we also talked a lot about types of electrodes, calomel, quinhydrone, and glass electrode. Calomel electrode, like I said, very important, has a diagram. So once again, I'm reminding you guys, if you have to draw a diagram, make sure you draw it beautifully. I know you have less time, 2 hours only, but make sure you practice the diagram enough number of times, the hand will automatically draw it. Okay, so you don't have to worry much. So types of electrodes, Nernst equation, electrochemical series is also very important. Then you have to, at the end, almost coming in, so second part, corrosion. So before I go, just give you a recap of corrosion. Once again, like I said, if you're finding this video helpful, if you found out that this 1 hour and 20 minutes that we spent together has helped you to get some clarity in terms of chemistry, please do share this video with your friends, with your classmates, on your Instagram. If you're posting it on Instagram, do tag us at Cynohub and in your WhatsApp classroom group chats as well. So whatever it is, for your classmates, for you as well, this is going to be very helpful. So coming back to corrosion, we talked about what is corrosion, why corrosion happens, because of oxidation of metals, and what are different types of corrosions that we have, dry corrosion, wet corrosion, different conditions of corrosions, and different types of corrosions as well, galvanic, waterline, pitting, as well as factors affecting the rate of corrosion, which is also very equally important. Factors affecting the rate of corrosion, like I said, it's small question but important, so sit down, learn it. And like I said, just like Unit 2, how do you defend against corrosion? How do you defend against the Thanos that is corrosion? You are going to defend it by using 3 to 4 different methods: cathodic protection, sacrificial anode, which are both very important, impressed current cathode, surface coating, electrolysis plating of nickel, which is also very important. So make sure you're remembering all of these. Unit 4 is going to be very lengthy as well as very kind of meaty subject. So kind of like while you're studying, make sure you're referencing a lot of Cynohub videos. Those are going to help you a lot. So start off with isomers. Isomers basically you remember, right? Different shapes, same formula. The chemical compounds having different shapes but same formula, isomers. And enantiomers and diastereomers, we talked about. Diastereomers we talked about. Enantiomers means the stereoisomers which are mirror images of each other but they won't overlap. All right. And diastereomers basically means they're not the mirror images of each other. So like I said, chemistry, once again, very interesting subject, easy to learn, easy to understand, kind of like not too difficult. It's something that we see in our day-to-day lives, so you don't have to worry if you're kind of like you're worried about the exam. So sit down, sit with me or sit with Cynohub. You can go through all of these videos, very easy to understand, and you can easily score. So that's the reason I was saying, do not think about pass marks at this point in time. Think about top marks, because you have so much amount of time and so good amount of resources, so powerful resources for you to study. So absolutely, you can absolutely go ahead and crush your exam. And once again, Unit 4, aspirin and paracetamol, structure, synthesis, and chemical formula. Then types of reactions, elimination, substitution, and addition. Also Markovnikov and anti-Markovnikov, Grignard, Zaitsev. These are some things that you absolutely have to remember. And coming to Unit 5, to end things off, spectroscopy, principles of spectroscopy, UV spectroscopy, IR spectroscopy, must, absolutely must. Very simple to learn, but absolutely must. NMR, we talked about NMR, nuclear magnetic resonance, also very simple, absolutely must. Nucleus, magnetic field, it resonates. It's that simple. So that's it. And chemical shift and NMRI. So these two are the concepts. If you just remember these, if you just learn these, Unit 5 is basically done, and that's how you finish chemistry. So if you enjoyed this, once again, that's the end of the stream. So if you enjoyed this, please do share them. Upcoming next, we have the physics live stream. So if you are somebody who's waiting for the physics live stream, the time is now 8 o'clock. We're going to start physics, and same just like chemistry, we're also going to talk a lot about physics. And for the future upcoming exams as well, BW programming, any exam it might be, we are going to be live. We are going to be discussing important topics. We are going to be talking about how to prepare for your exams. Cynohub is here for B.Tech students. Cynohub is going to help B.Tech students not only pass the exams but also to crush their exams, to crush their JNTUH exams and score a lot more than just 80%, a lot more than just 40-50%. We are going to help you score 70 or more than 70%, hopefully 80. Alright, with that said, thank you so much for staying patient and staying till the end of the video. I hope most of you are here, and if you are, that's it for the end of the video. You can all take your leave now. Go to www.cynohub.com or go to Google Play Store, search for Cynohub. It's CYNOHUB, and prepare for your exams with all of your lecture notes, study material, previous year question papers, and your lecture videos as well. Alright, that's been me. Thank you so much for watching, and I'll see you in the next live stream. All the best for your exams.